Hey, it's Alex Williams, the New Stack, here at OpenStack Silicon Valley at the Computer History Museum in Mountain View, California. And we're here, during the lunch hour to get a demo of Kubernetes 1.3 from the CoreOS perspective. And I'm here with Brandon Phillips, CTO and co-founder of CoreOS, and my colleague at the New Stack, Joab Jackson. Great to see you guys.
Hello. Thanks for having us.
Great. So, Brandon, why don't you just give us your perspective on Kubernetes 1.3 and just take us through it and what you guys are thinking about it and why it's significant to you at this point.
For sure. So CoreOS are big contributors to Kubernetes. And what we did in 1.3 is we had a bunch of features that we thought were really important for these enterprises to actually start to adopt Kubernetes, to extend their success that they've seen in their labs, the successes that they've seen with the product so far. And so what we did was we looked through what are the things people are asking for in Kubernetes and our Tectonic product, and started to kind of push forward on those things. And pretty much we got everything that we wanted out of that release done. So I kind of walk you through what we were doing. So like I said, we're all focused on Tectonic, which is our enterprise Kubernetes product. And the idea here is that we package up Kubernetes and we provide kind of an enterprise-ready set of updates and platform for users. Now, so what we did in the V1.3 release is we added a number of really important features that Kubernetes was missing till now. The first is that we added OpenID-backed authentication. And so OpenID is this kind of really important fabric for the entire web. It's the identity that is in your Google identity, the identity for your GitHub identity. And then we have an OpenID Connect provider called Dex that you can back by LDAP or any of these other enterprise providers. And so by bringing that into Kubernetes, we're able to give people the ability to, in their existing Active Directory or LDAP environments, hook up Kubernetes and have their system administrators and their developers use their regular enterprise identity and be able to deploy and manage applications on Kubernetes. So that's the first thing that we did. The next is that it's not enough just to say Sally or Joe did something inside the cluster. You actually have to start to have groups and roles. And so Kubernetes until now, you essentially were able to log into the cluster and do anything in the cluster, no matter if somebody else did the work, or be able to read and write all over the place. What's really cool in Kubernetes V1.3 is we added this idea of role-based access control. So you're able to say, Joe belongs to this group of system administrators that manage this app. And you start to partition up the Kubernetes cluster in a way that's actually pretty useful, and in a way that enterprises expect to be able to slice and dice this stuff. And so that's a fully API-driven system. And inside of our Tectonic console, which is our single pane view of glass into Kubernetes, we've added the ability to add and remove groups and manage these users through this role-based access control. And then we've been doing a ton of work in simplifying the installation and upgrades of Kubernetes. We've been working on AWS integration. We have a really successful tool called KubeAWS that helps to bring up Kubernetes clusters in what we feel is a production-ready setup for AWS. People were kind of building this themselves and with various degrees of success, and so we wanted to kind of package up best packages into a tool. And then we've also started to do a bunch of foundational work into something that we call self-hosted. We recently wrote a blog post about this, but this is the idea that Kubernetes has a lot of moving parts, has always been perceived as a complex system. What we want to do is simplify that down so that actually parts of Kubernetes can be managed through the API. So you're able to do, say, an upgrade from V1.3 of Kubernetes to V1.3.2 Kubernetes completely from the Kubernetes kubectl API tool. So Kubernetes is actually starting to manage itself, which is really powerful. As we start to get V1.3 into Tectonic, you'll start to see our ability to deliver automatic updates similar to what we do for CoreOS Linux happen. The next bit that we did was Kubernetes scales really well today. It's able to scale pretty nicely to about 1,000 machines. And what we did is we've been working really hard on etcd. etcd is this database that we built that's the primary data store of Kubernetes. And in this database, we've been working on making it scale to really, really large numbers of machines and clients working with it. And so we introduced etcd v3 and that support into Kubernetes. And this will mean that etcd will be able to scale up to whatever new limit Kubernetes wants to go to. We're happily expecting it to be able to scale up to 10, 20,000 machines inside of the Kubernetes cluster without any problem. And then a sort of alpha feature that got introduced into v1.3 is that we integrated our Rocket container runtime into Kubernetes. Up until now, the primary runtime, or the only runtime of Kubernetes that was supported, was the Docker engine. And with this change, Kubernetes is able to run on top of the Rocket engine as well. This is pretty exciting. We have a number of customers that like some of the properties of Rocket, being able to run, say, Kubernetes pods inside of virtual machines, being able to do things like interact with Rocket and pods that have been scheduled on their virtual machines or their physical gear in the same way that they interact with any other process that's running on those machines is pretty important to a lot of these users. And so it's currently marked as an experimental feature, but through v1.4 and beyond, we're working really closely with Google and a bunch of other folks to make this a first-class citizen inside of the Kubernetes community project. So that's kind of a quick rundown of everything that we've been doing, and at least a little taste of the motivators of customers that have been asking for these features and what's causing us to do this work.
Excellent. So with the Rocket support, would you be able to combine Rocket containers and Docker containers in the same pod?
Yeah, so this is a pretty common question. I think what happens a lot is people confuse the term Docker with a lot of different things. So
Sure.
the primary thing that I think users care about is their Docker image. And Rocket can support running Docker images, open container images, and then AppC images. And so inside of Kubernetes today, you'll be able to run a Docker image just as if you were running any of the other types of images under Kubernetes with Rocket. So that's not a problem at all. In fact, if you're using the Rocket container runtime, if you're a user of the Kubernetes API, nothing changes for you. It's the infrastructure and the way that the containers are ran on the back end that's actually changing. It's more of an infrastructure change than anything else.
Is there good reasons to run different types of containers under one pod? I mean, are there advantages for each? Are organizations thinking this way?
Yeah, right now most of the organizations are thinking about just, these are my container images. They really aren't caring about the format much. I think the reason the formats are important is that it gives it creates a market. Like, you need some sort of standard similar to what HTML5 did for the browser market. You need some sort of standard so that Jenkins can have their container image building extension, and the cloud providers can provide their container hosting extensions, and everyone can kind of work in the same model. And so for us, we're not super opinionated. Kubernetes is not opinionated on which image formats you run.
Right.
We wanted to be able to use and run whatever images you have. But we have a certain opinion, and our customers have a certain idea of how those things get executed once they land on the machine. The image is kind of orthogonal from the running side.
So the authentication, how does that fit into the story with Rocket?
Yeah, so the authentication, Kubernetes has this really nice separation of concerns. So you have the API layer of Kubernetes, which is essentially where 99% of the work happens. You get your logs out of the API server, you schedule new work through the API server, everything goes through the API server. So Rocket isn't really aware that any authentication has been added to Kubernetes. It's all about that API server. And that API server drives decisions downwards towards the machines running the containers. And that's kind of the architecture of Kubernetes, is that these machines that are running Kubernetes, what they're actually running is just this little piece of software called the kubelet that talks to the API server and says, I want this and that. And these two things are authenticated. And then the user only talks to the API server. And that's where we've added the authentication, is through that API server. And so, yeah, the authentication work that we've done applies to any configuration of the kubelet.
Excellent. Role-based access control. I know this is something that historically enterprises have been really, it's an important feature for enterprises. Can you say how it can be used? Obviously, this can be used for logging who does what, but also I imagine it could be used from stopping people from running jobs that they shouldn't be run, or what's going on?
Can it fit with policy then too?
Yeah, for sure. So there's Kubernetes today has a bunch of different capabilities for policy. So you can have things like network policy. So you could have the role-based access control say, we have our network administrator role, and those people in that role, they're able to manipulate the network policy for the entire cluster, but they're not able to say deploy a new application or change an application from version 1 to version 2. Mm-hmm. And so the role-based access control is really, really generic. We simplify it through the Tectonic console, but you're able to attach roles to any sort of resource inside Kubernetes, whether that's a policy, whether that's an application, whether that's a service that's doing load balancing. Any of those things can have a access control policy assigned to them. So it's a nice, really flexible system that we put together, and we've worked with Red Hat and Google and a bunch of other folks in the Kubernetes community to make it happen.
So you have the authentication, you have Rocket, and you also then have this API that you've developed to really automate the processes, to abstract the complexities?
Yeah, so the work that we're doing on like the self-hosted stuff is to make it a lot easier to understand what's deployed inside of Kubernetes, what are the components, and then to be able to like get logs out, to be able to roll upgrades to them and that sort of thing. So we're leveraging essentially the Kubernetes API and giving people the same power that they have deploying their applications to Kubernetes to be able to manage their Kubernetes clusters themselves. It's a little chicken and egg, a little turtley, but we think over time it'll be a nice way of managing the complexities of Kubernetes and making it actually feel like a concrete piece of software that an operator can confidently manage over time. Really, all this stuff, that's what it's about. The reason we're seeing such strong adoption of Kubernetes is it allows customers and users to cut out that big part of software lifecycle that they always had to reinvent. That first like 6 weeks or a quarter of work of, all right, I have my code going through CI/CD, now I hook it up to some automation to get it into whatever our environment is, and then it hooks it up to a load balancer to add in those things. Kubernetes is removing that whole pipeline, and we want Kubernetes itself to be able to manage in a similar manner. That's some of the work that we've been doing.
One of the aspects of Kubernetes that people tell me that is really valuable about it is that granularity that you can have, and that's where the complexity starts to really manifest.
Right.
With this API, how can you maintain that ability to have that granularity?
Yeah, so we've attacked, so on the role-based access control stuff, we've attacked it in 2 different ways. One is that we, inside of the Tectonic console, which is the graphical interface to Tectonic, we provide a really simple things. So there's this idea of namespaces inside of Kubernetes. So right now you see there's a couple of different namespaces in this cluster. And what we do is we say that there's people either have read-write access or read access to a namespace. And namespaces are generally used for, say, a single project or application inside of an environment. So I have my, marketing WordPress namespace. And so inside of there, you'll give, 2 engineers the ability to rewrite access to it, and maybe an on-call engineer read access to it. So we try to simplify into like a common use case, a very simple way of managing it. But then on the through the API and on the command line tools, you can do kind of like build your own mode and go super advanced and do as you wish, individual resources and individual namespaces and that sort of stuff, and get a lot more fine-grained with it. And I think that over time you'll see a lot of these things happen inside the Kubernetes. It's really important that we allow for flexibility. That's why Kubernetes has gained such widespread and like rapid adoption. But at the same time, you have to create very specific channeled user experiences for enterprises so that they are familiar and able to like actually get the expected outcome out of the system.
Excellent. How are you seeing Tectonic / Kubernetes being used by the enterprise? Are they doing pure microservices implementations? Are they doing what sort of things are they using it for?
Yeah, a lot of what we're seeing initially are essentially these applications where they would have been building up that CI/CD like deployment pipeline fresh. So these are systems like API systems for powering their applications or their websites. These are internal like job systems for like running reports and that sort of thing. And then long-lived services, whether they're like taking in and processing user data or whatever. So we're seeing a mix of different things. We have seen at this point in the adoption cycle of this technology, we've seen more new applications that are being built fully on top of Kubernetes from scratch than migration of existing applications. That's becoming a very common question is, I have my existing Java middleware application. It has these microservices that are built out in this particular way using a Java framework. How do we map that to the Kubernetes world? And those are conversations that we've started to have over the last few months. And we'll continue to like figure out and identify the things in Kubernetes that need to happen in order to make those things successful. So yeah, today, a lot of greenfield. We're moving and seeing more and more interest as these greenfield projects have shown success. And as we see more companies building on top of Kubernetes with good results, we're seeing more of the brownfield applications start to move over, at least road mapping for those things.
So what's next with Kubernetes?
Yeah.
Beyond 1.3?
Yeah, so 1.4.
Yeah.
1.4 is the next release. And inside of there, we are continuing to push forward on all this stuff that I just talked about. So getting role-based access control into the stable version of the API. Right now it's in the alpha version of the API. Pushing forward on top of Rocket, making it more dynamic over time. There's a bunch of features that we would like to add inside the Kubernetes API that we want to be well supported by Rocket. And then really V1.4 is a quick maturity release. And so V1.3 came out, added a bunch of features. V1.4 is the follow-up where we're polishing those features, moving a lot of them towards stabilization. And then there's some focus on scaling as well. So we want to increase, yet again, release after release, focusing on where Kubernetes can move to 1,000, 2,000, 3,000, 4,000 machines and beyond as it's able to reach maturity and support these larger and larger deployments.
Is this being driven by customer demand? Are you trying to stay one step in front of customer demand, or why the push towards scalability?
Yeah, so there is quite a bit of customer demand, particularly in dynamic cloud setups. So folks aren't running like 3,000 machines all day, but at certain times of the day, they may want to scale up their clusters and then scale them back down for, say, they're doing some large compute workload or some batch job workload or something. So we're seeing it on that side. And then also, like, to be perfectly frank, like, people want to know that they're building on a platform that's going to support them over 10 years, 12 years, over a long period of time. If they're going to be making a major investment, rebuilding and rethinking their deployments and application life cycles, they want to ensure that that thing's going to scale as they plan out their data centers over the long term and as their compute footprint increases. So in that way, we have to increase scale to ensure that there's the confidence that to be able to grow into Kubernetes over time.
In the process, the open source community is really starting to scale, isn't it? How is that management process going?
Yeah, so Kubernetes, Brian Grant from Google and I had a really great conversation about this, but Kubernetes is, I believe, the largest project on GitHub right now. There's no larger open source project with more people involved, more commits going through, and that sort of thing. And so that's something I'm super passionate about. I've been an open source guy for a long time. And we've been working on, how do new Kubernetes projects come into existence? What are the release milestones? We've been working on, if people are interested in following along with Kubernetes, there's this thing in the features repo. We've started to track individual features, the major features for every release. And so if people want to see, like, hey, what's up? What's going to happen with the next release of Kubernetes? You can actually just drill in here and find what are all the major features that are happening in V1.4, which is the next release coming up in the next few months. So we're going through a learning process, but it's definitely a dynamic, growing open source community, and we're putting the processes and the maturity in place so that we can deliver releases on time and that people get their expected outcomes from every release. So.
Well, great. Well, that's a topic of real interest to us. We look forward to following up on that. Brandon, thank you very much for taking the time to talk to us. Joab, thanks for joining in this conversation, and we look forward to keeping up with Kubernetes and CoreOS.
Cool. Thank you, guys.
Thanks.